Hey guys, Darian Giuseppe here, back again with another video for the key concept series. What just happened there? I don't know. So I'm back again with another video for the key concept series. We are looking at a question on module 3 for Pure Maths Unit 2. This question is based off of the topic of matrices. So with that said, let's take a little run through the solutions for this question here. The question says that a system of equations is given below. So this is the system of equations. We have 3 equations. They are asking us in the first part to write the system of equations in matrix form. So this is actually pretty straightforward. There's probably just a 1 mark to convert this to matrix form. It's just a matter of taking the coefficient of each one of the terms and creating your coefficient matrix, and then creating the other 2 column matrix, one which would have x, y, and z, and then this next column matrix with just constants. So basically part 1 is simply this: your coefficient matrix, your 2 column matrix. So they say write the system of equations in matrix form. This is basically it. That's your solution there. That's probably just a 1 mark, right? So you want to just do that. That is simple stuff, right? The next part says show that the determinant of the 3 by 3 matrix is 10. So this is the 3 by 3 matrix here, right? It is 3 by 3. The order is 3 by 3. That's this one here. Can't be this or this, obviously. So we're looking at the determinant of this guy here. So what we want to look at is that how do we go about finding the determinant of this matrix? That would be the big question. So we would be looking at, let's write down the matrix, right? So this is what we want to find the determinant for, this 3 by 3 matrix. What we need to do is use the cover-up method. We want to focus on the first 3, right, elements in the matrix, and we want to use the cover-up method. We want to take the element and multiply it by the smaller matrix that will be formed when we cover up the element or the row and column that the element is found in. So you're taking the 3 and multiplying it by this matrix here, this small 2 by 2 matrix. So that's the cover-up method. And let's take it one step at a time. Let's look at this first, right? When we take 3 and multiply it by this 2 by 2 matrix here, but we're multiplying it by the determinant of the 2 by 2 matrix that is formed when you cover up the row and column that this element is found in. So we're looking at the first, let's look at the first term, 3. So 3 would multiply by the determinant of this 2 by 2 matrix. So let's look at that first. So it will be 3 by this here. And then let's look at 2. So to get 2, we will take 2 and let's cover up the elements in a row and column of 2. So you'll be left behind with these 2 and these 2. So these 2 would form your 2 by 2 matrix that you're going to find the determinant of, and you're going to take this 2 here and multiply it by the determinant of that 2 by 2 matrix. But the key thing with this is to remember is you need to change the sign. This is where the determinant is you need to remember this, right? You wouldn't be multiplying by 2, you'll be multiplying by -2. So that's key. That's very important to note. So it's actually -2 by the determinant of this small 2 by 2 matrix that would be formed from these 2 here. So that's cool. Just remember that -2. That's a common error to forget it. And then the last thing we have to do is look at this term here. And we do the cover up again. We cover up all the elements in the row of that term or element, and the column as well. So what you notice is you would have -1 being multiplied by the determinant of this small 2 by 2 matrix. And that's basically what we will have here. So all we need to do is from CSEC days or form 5 days, you would know 2 by 2 matrix, the determinant is this term by this term minus this term by this term. So that's basically what you're doing. So you do that here, 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 and you multiply them by the terms in front here and here. And just add everything together and you should get the answer. So let's go through it. This is what we will have here. Be careful with your signs, right, guys? So you could probably just pause the video, take a look at it, right? You would have the negative 1 by 1, that's how you get this negative 1 here. And then the 2 by negative 3 would give you a negative 6. Right, so your setup is very key. Right, these two negative signs very key. So we want to make sure and be very careful. Right, you check this as well, just make sure this is okay. Let's just make sure you would have 1 by 1 would give you a positive 1, and then the 2 by the negative 2 would give you a negative 4. And remember, it's always the product of the two terms minus in each other, so that's why I have that minus there. And then again we have 1 by negative 3 would give you a negative 3 there, and negative 1 by negative 2 would give you a positive 2. So you have positive 2, but it will be minus, right? And then you could just actually put all this into a calculator if you wanted, but let's simplify a bit. This is what we will have, and in the end you should get the 10 that they ask you to show, right? Remember, they said to show that the determinant of the 3 by 3 matrix is 10. So it is in fact 10. That's our answer there. Pretty straightforward. And we get 5 marks there. Then this next part is asking us, or it says actually, given that the corresponding cofactor matrix is, so they give us a cofactor matrix, that's really nice. They're asking us to find the values of x, y, and z. What should come to mind immediately is that you need to find the inverse of the coefficient matrix. That's what you need to find, the inverse of that. And once you find the inverse of that, you can be able to find this here, x, y, and z. But to find the inverse of a matrix, you need to multiply the matrix, or you need to multiply one of the determinant by the matrix of cofactors. So of the matrix of cofactors transposed, right? So the inverse of a matrix, A inverse, right, is equal to what? 1 on the determinant of the matrix by the cofactor matrix transpose. So that's what should come to your mind immediately where this is concerned. So we actually have the determinant already. We have the cofactor matrix here. So that's really good. They gave us it. So we just really and truly just had to transpose that. But I'm just going to do this part kind of a little bit lengthy. I just go through the exact steps that I would, well, you don't need to go through these exact steps in the exam, but I'm just going to go through it just as a teaching moment. So let's just look at it. Let's just look back at this here, the system of equations, or sorry, not the system of equations, but the matrix form for the system of equations. Let's just look back at that, just put it down. And what we normally do when we have the system of equations in the matrix form, we normally let the coefficient matrix be A, let this be X, and let this be B. So that's what we normally do. We kind of set it up nicely, right? And as I said before, there's just a teaching moment. You don't need to have, or you don't have to do all these steps when you are going to or trying to find X, Y, and Z. So we could rewrite it like this here, and then we could pre-multiply by A inverse. When we pre-multiply by A inverse, this is what we will get happening here. The reason why A inverse by A would give you I, which is the identity matrix, and the identity matrix by any matrix is itself. So that's why we have X there. And X, remember, X is the same as the column matrix, right? So X, which is what we need to find, the column matrix, the values of X, Y, and Z, is given by A inverse by B. That would be key. So this is what right, is very important. We actually have B, but we don't have A inverse. So that's why we need to find A inverse. And A inverse is given by 1 under the determinant by the cofactor matrix transposed. And well, you obviously had to multiply it by B as well. So we know the determinant is 10, and the cofactor matrix transposed is basically you're taking this and you changing the rows to columns. So you notice this here will change to a column here. Notice that. And row again, this row here, change to a column. You notice that? Just look at it, pause the video, and just take note of that. Row here, turn to a column. That's how you transpose it, the cofactor matrix. And know this formula as well for the inverse of the matrix, right? 1 under the determinant by the cofactor matrix transpose. That is very important for a 3 by 3 matrix to find the inverse. And well, you just replace B with the values there. And now it's just a matter of multiplying rows by column, this by this by this again, and this by this again, and you should get the answer. And this is what we will have up here. So x would be equal to the 1 and 10 multiplied by, if you multiply this by this, you should get this. Just check it out. If you multiply this by this, you will get this. And then this by this, you will get this. And lastly, we just add up these, and see what we will get. We get this here, 30, negative 10, 50. And then we just take this 1 and 10 and multiply it by each one of these terms. And we get x is equal to 3, negative 1, 5, which implies that x is equal to 3, y is equal to negative 1, and z is equal to 5. So that there is your solution for this particular question, right? Remember, they asked us to find the values of x, y, and z. Always remember what the question is asking you, and give the question, or give the people what they want. That is what I want to say. Give the people what they want. That is very important. Don't stray. So with that said, guys, this is the solution to this question. It's a matrices type question. They like to bring this. They will bring this in the exam. Like the video, guys. Share it to a friend that you feel it will be beneficial to. And subscribe to the channel. And I will see you in the next video.